Hey guys, today I'm going to talk to you about solving oblique triangles with something called the law of sines. So we've been talking a lot about solving right triangles. We do right triangle trig all of the time, finding missing sides and missing angles. But today we're going to look at the law of sines, and this is used to solve oblique triangles. And that basically means you just have your regular old triangle, there's just no right angles. So it's not a right triangle. And right here, this is your law of sines. And I know it looks a little bit interesting because it has two different equal signs. So it's a ratio of the sine of angle A over side A. And that ratio is equal to the sine of angle B over side B, which is equal to the ratio of sine of angle C over side C. So the first thing that's important is the setup of any triangle. When I'm talking about angle A and side A has to be directly opposite angle A. So this would be side A. And we typically do sides with the lowercase letters and then your angles with the uppercase letters. So then this side over here would be side B and this side over here would be side C. And at any given time, you're only going to be using two of the three ratios at one time for one problem. So you're not actually going to have all three parts at one time. You're only going to have two parts. So the time that you're going to use the law of sines, because of course there's also a law of cosines, and we'll get to that next week. So you do have to be able to decide when to use law of sines and when to use law of cosines. So there are three different instances based on information that is given to you that you want to use the law of sines. So the first instance is if you are given angle, side, angle. And what this means is, let's say if this is your triangle, if you're told that this is 32 degrees, and then the side next to it is, let's say, 10, and then this angle, let's say, is 20 degrees, you can see that you have this angle, this side, and this angle. It's angle, side, angle. So if that information is given to you, you can use the law of sines to find either this side over here or this side over here. Another situation would be if it were angle, angle, side, meaning that in your triangle, if you said this angle was 32 degrees and this angle was 20 degrees, instead of the side being in between them like it is here, the side would be something like over here. Like if this side were 15, you have angle, angle, side. And then the last case, and let's see if I can move me out of the way there. The last case is actually, we would write angle, side, side, but I'm going to get creative and write side, side, angle, and hopefully you can tell why. If you have that, then that means that you have, let's say, this side is 11 and this side is 14. It's not the angle between them because that would be side, angle, side. We want side, side, angle. So let's say this angle over here was 24 degrees. Okay, so in these three instances, that's when you can use the law of sines. So now let's actually practice that. So here's your first example. And the first thing you always want to pay attention to is what's given to you. We can see that I have two angles and then the side that is directly in between them. So this situation is angle, side, angle. And we've already said angle, side, angle. That does mean that we want to use the law of sines. And it looks like here we are looking to find side B. Well, side B is this side over here. Okay, now when you're setting up the law of sines, like I said, you're only ever going to use two of the ratios, right? So one equal sign. But the biggest thing here is that one of those ratios has to be complete, meaning that you're not going to have the letter A on top or on bottom, or the letter B or the letter C. It's going to be complete. You're going to have the sign of an angle that's given and that side that's given. But here I have angle B, but not side B. I have angle C, but not side C, and I only have side A. But we do know what angle A is. We can easily calculate that because we know that all three angles in a triangle add up to 180 degrees. So to find angle A, let's do that first. We would take 180 and we would subtract 34 and 80 degrees. And so we would be able to figure out that angle A is actually 66 degrees. So now that I know that, since I have angle A and side A, I could say that the sine of angle A, 66 degrees, over side A, which is 16. So this is what I mean. I have one complete ratio. And then based on what it is that I'm trying to find, that's going to be the other ratio. So since I'm looking for side B, then I need to use the sine of angle B, which is 80 degrees. And now you have a proportion. And we're very familiar with solving proportions. We've done that before. So we just need to basically use our cross products, right? We know 16 times the sine of 80 equals b times the sine of 66. So to isolate b, that means we take 16 times the sine of 80 and divide it by the sine of 66. The biggest thing is you need to make sure that your calculator is in degree mode when you type this in. And you should get, if we're going to round, let's say to the nearest hundredth, you would get 17.25. And you could just put units on there if you wanted to, but just leaving it 17.25 is fine with me. Okay, so that's our first example. Keep in mind, if I did ask you to solve the triangle, if you had to find side C, you cannot use Pythagorean theorem. This is not a right triangle. So if I also asked you to find side C, you would actually have to go through and use the law of sines again to find that side. Okay. So example 2, sometimes it might be given to you like this instead of a picture. In that case, I would, before I can answer what information is given to you, I would actually just draw a triangle and label it to figure out exactly what situation has been given to you. So it doesn't matter where you put your angles. Let's say if this is A, B, and C, then this angle A is 22 degrees and angle B is 95 degrees and side A is 420. So across from that, 420. So in this case, we have two angles, but the side that is not between them. So we were given angle, angle, side. So that means that we are going to use the law of sines again. It looks like in this case, we are also looking for side C. So I'm looking for this over here. And right now it looks like I have this angle and this side. So I can use for my completed proportion, for my complete ratio, I have everything for A, right? So I have the sine of angle A, so the sine of 22 degrees over 420 equals, now I'm looking for side C. Right now, again, I wasn't given angle C, but that's something that we can easily find by taking 180 minus 22 and minus 95. And so it looks like, let's see, angle C here, if I type this in, do I have that? It would be 62 degrees, right? So if this is 62 degrees, then I can just take the sine of 62 over C, and there's my completed formula that I need there. So that means that I'm going to take, let's see, whoops, I think I'm using the wrong one. I am using the wrong one. That is not 62 degrees, it's 63 degrees. So if you caught that, good job. Don't mind me, just let me fix it so I don't have to re-record this whole thing. So 63 degrees. So typing that in to get side C, we're going to do 420 times the sine of 63 divided by the sine of 22. And we get that C is what? 998.98 units. And a quick check is angle C, 63 degrees right here. This is larger than 22 degrees, so I should be expecting that my side C is longer than side A, since angle C is bigger than angle A. So that's kind of a quick check for you. So there are two more examples on this worksheet. I'm going to encourage you to try them first on your own. I know that so far we've only talked about angle, side angle, and angle, angle, side. The side, side angle, which if I spelled backwards would be the bad word, this is a special case, okay? So we're going to come back to this. We call this an ambiguous case. That's going to be in your next video. But go ahead, pause this video for now. I want you to try the next two examples on your paper and then come back and check, okay? Just try it. Don't freak out if you're not 100% correct, but look at my work to double check yours a little bit more. So I'm hoping that you paused it and now you're coming back and you can see my answer here for number 1. The first thing I did was solve for angle R after I figured out it was angle, angle, side. I solved for angle R as 114.2 degrees. Then I used my complete ratio that I got from angle Q and side Q. And then I did sine of 114.2 over R, and solving for R, I got 7.28. And then number 2, which I'm sure you paused the video and you tried it on your own. Number 2 was an angle side angle problem, and I got that angle, angle A was 50 degrees, B was 68, and C was 230. So knowing all of that, I could also get angle C was 62. You can see the two ratios that I set up and the completed proportion. So then A was about 199.55. And go ahead and check out the next video for side-side angle.